Hey, thanks for joining me today. My name is Jeff Reedy. I am the CEO and co-founder of Scale Computing. My talk today is entitled Redefining Virtualization. Really, what I want to address is the fact that over the last 12 and 18 months, there have been a tremendous amount of changes in the world of virtualization and disruption to the industry. And many of you have likely been using the same virtualization platform for decades at this point. And over that period of time, what you may not have realized because you were using the same system is that there have been tremendous innovations made along the way, new technologies, even beyond traditional hyperconvergence, hyperconverged 2.0, using AIOPs to automate the administration of systems, to automatically detect problems and recover from them. To be able to run virtual machines and containers side by side on the same platform while mixing and matching all of this together. And that's really what I want to talk about, because the opportunity that's presented is that as you're looking to move to a new virtualization platform, is you can not just get an apples to apples switch, but you can actually pave the way for the future of your infrastructure to be able to embrace things like edge computing. Interestingly enough, 10 years ago, 12 years ago, the cloud was kind of viewed as a location to run applications. And so the cloud was a big data center. And if you went back and looked at the Gartner Magic Quadrant from 2007, you would see not the cloud as we know it today, but the companies you would see would be large data centers. But of course, what we know the cloud is today is it's not just a big data center, a big hosting company, right? It's all about, can you rapidly deploy and change the way applications are developed, have integrations in applications, and change the way you manage that infrastructure. And that's what the edge is becoming. The edge just doesn't mean remote office again, right? The edge means a series of disparate locations which can be managed and orchestrated in such a way that does create a private cloud. So what I will show you, and most of this is going to be demo, but what I'm going to show you is a product called SC Platform. So that's Scale Computing Platform. This is our platform for running applications. It's made up of two main components. One is called HyperCore. HyperCore is the software that gets installed on your server. You can think of it in, from whatever solution you're using today as the virtualization platform, but it is a combination of virtualization containers, integrated storage, built-in disaster recovery, built-in high availability, the use of AIOPs to automate error detection and correction. But all this is standalone. It goes on the server. That server is sitting in some location, whether it's a data center or a ship at sea. It could be any of these sorts of things. Then that series of locations ties into what you see on the left, which is called Fleet Manager. And Fleet Manager is effectively the centralized portal that turns your virtual deployment into a private cloud. So whether you are a small company that has a single server running in one location, you can still use Fleet Manager to access your environment, no matter where you are, at a trade show, at home, on the beach, whatever it may be. Or if you have 100,000 servers across thousands of locations running all kinds of workloads, that too can be managed in Fleet Manager. Effectively, it is a cluster of clusters. And it's not just, can I access my systems? It's actually, do I orchestrate the management, the deployment of applications such that I can treat that one location or those 10,000 locations as one unit and interact with it the same way that I would interact with the private or the public cloud, rather. The key components I talked about on the last slide, but they all fall into these four categories, right? One is high availability. Two is simplicity, and simplicity more than just the user interface. It's the automations, and this is where the AI ops comes into play, recovery from failure, that sort of thing, keeping applications up and running. Efficiency. So I mentioned hyperconvergence. One of the knocks against traditional hyperconvergence is that it consumes a tremendous amount of resources on the servers that it's installed on, sometimes north of 50%. You won't see that here. So new technology to change the way that HCI is done. You're going to see it's very lightweight while still delivering on the speed and capabilities that HCI can bring to bear. And finally, flexibility. Again, whether you're running one locations, thousands of locations, big ones, small ones, large organization, tiny organization, you have lots of flexibility in terms of how you deploy the system, in terms of how you mix and match hardware to create clusters, all those sorts of things. For those that don't know scale computing, again, I started the company about 16 years ago. We are a virtual platform for running applications. And so, we're most known for sort of combining high availability with extreme ease of use powered by that AIOPs model, and that delivers a radically reduced costs. So if you find yourself that somewhere in your infrastructure there is one or more environments, maybe your whole environment, where high availability matters, where you have limited IT resources, where you want the flexibility to run legacy applications, modern applications, from old, 30-year-old VMs to new AI inference models, that is quite possible on the Scale Computing platform. And we do work with partners all over the world to deliver to tens of thousands of customers today. Two quick examples, and we won't spend much time here, but just to illustrate the breadth of the applicability of what I'm going to talk about here. So whether you are a large global enterprise being managed in part by something like Accenture, right? Complex industrial production like Coca-Cola, down to an individual gas, fuel, and convenience store. So some on the East Coast may recognize Royal Farms. It is a fuel store, gas station, famous for fried chicken. And so I think the important thing here is whether you are running, critical applications on the factory floor, like Coca-Cola, or whether your critical application is the point of sale system that allows you to sell chicken, it is still important to you, right? And you need a platform which is flexible enough and easy enough that it can deliver those applications to your users in a highly available manner. So I'm going to dive into the demo here. What you see on the left are the features I am going to show in the demo. Overall, you should naturally see the ease of use of what I'm talking about. I'll reference the AI model that makes this work in a bit. That hyperconverged layer that I mentioned, you'll see is very lightweight. Built-in high availability, so when something fails, the system takes action to keep the applications up and running. Integrated disaster recovery. I will deploy a disaster recovery solution while we are in the demo. It takes just a few seconds. So complete site failure doesn't result in downtime. We'll talk a bit about zero-touch deployments and break fix. It applies more in edge computing environments, but can be used anywhere. The ability effectively to stand up a new server simply by plugging in hardware and having it download and install all the software it needs to completely on its own. And finally, we'll wrap up talking about migrations from legacy platforms and how you would move from what you're using today over to something like SC platform. So let me dive in now to the demo. And so I'm going to come over here, and I'm now connected to Fleet Manager. So if you look at the top, fleet.scalecomputing.com. So I've logged in here. I can see my entire environment. Now, the environment that I'm showing you is 36 clusters. It could be many more than that. It could be less, but 36 clusters. I can quickly at a glance see the state of any of those clusters. Normally, you'd want them all to be healthy. That doesn't make for a great demo. So you can see my environment here. I've got all sorts of things that can draw my attention. But as an administrator, I would log in. I could quickly see, hey, this is the stuff that needs some attention. Some of it might be critical. You can see I've got a drive failure. I've got some kind of data redundancy degraded, likely because of that drive failure. In this case, maybe I've lost a full node. Other things are just warnings. I can't send email alerts, right? You see that sort of thing. So let's take a look at the cluster tab. And these are all the clusters in my environment. So again, Fleet Manager is sort of a cluster of clusters to manage everything. And I can see what's going on. And I'm going to come down to one of these clusters here called US 3350F. I'll click that, and I can see, some history information on the CPU, RAM, and storage. That's cluster wide. So this is a 3-node cluster. I can see the individual nodes here where my mouse is highlighting. I can see CPU, memory, and disk across each of those individual servers, as well as the cluster as a whole. So if I were troubleshooting and say I was seeing some kind of warning and maybe I was running low on storage, well, I could come here and see, okay, when did the storage start to spike? In this case, right, that didn't happen, but you can envision how you would use this in a troubleshooting way. And then kind of below all that, you can see the individual applications which are running on this particular server. So there's a button here that says Go to Cluster. I'm going to click that. It's going to use a technology called Secure Link and allow me to connect remotely into this cluster no matter where I am. So long as I can log into Fleet Manager and I've got the right credentials, I can then connect in to that cluster. Now, if I were local to this cluster, I could log directly into this interface as well. But in this case, I was remote. And so I've connected into this cluster. Now, again, it's a 3-node cluster. Each of the nodes has about 128 gig of RAM in them. And you can see at the top, cluster-wide, I've got 36 cores, 375 gig of RAM, 20 terabytes of storage, et cetera. The little grayed out area you see at the bottom here is what's reserved for the system. So the system is going to consume some resources for the AI model, for the virtualization, containerization platform, as well as the hyperconverged storage. So in this 128 gig of RAM system, the HCI is going to consume about 4 gigs of RAM. So it's very, very lightweight. You can even go smaller than that if you had a small system. You can run a single node and it would consume less than that. But again, it's almost transparent to your resource allocation, yet you get all the benefits of having that pooled onboard storage. The storage, as you can see from this disk icon here, is pooled across all of the system. In this case, I've got 4 drives per node in the cluster, but that can be mixed and matched. Could have different configurations. These squares you see are the workloads that are running in my environment, whatever they may be. And what I'm going to do, just for demonstration purposes, is to deploy a new application. So I hit the plus button, and we will call this Jeff Test. And so, we're going to do a Windows install here, but anything to virtualize on x86 work fine. CPU, memory, and drive allocation. I could add drives if I want to, et cetera. And I can say I want to boot from a particular image. So I'll do Windows 11 is fine. Hit create, and that's all I need to do. So I'm not configuring storage anywhere. I'm not, whether virtual, traditional SAN or in a virtual SAN, there's no storage controller, no virtual controller to manage here. That was all sort of transparent. So that literally just click a few buttons and you're ready to create that virtual machine, which is here. When I hit the power button, it's going to load balance the system across the system, pick one of the nodes to start that workload up on. I can pin it to a node if I'd like. Generally, just let the system decide what it wants to do with it. It picked the first node in the cluster in this case. So it's now running on that node. And if I click the console button, it'll be the world of installing Windows, because I did a generic Windows install, but you get the idea. Now, even while I'm still installing the underlying operating system, the guest operating system, it's already highly available, and I'm going to show you that. But I could do things like live migrate that workload right now. So I'll hit the arrows and I say I want to move that over to node 3. So it's going to do that. That usually takes 10-15 seconds for that to happen. Because the storage is universal, right? The storage is pooled across all nodes in the cluster. So I'm really just copying the RAM state from one to the next. And you may have seen a little wiggle that moved over there. So the UI is going to update here, but I can see that's already running on node 3 in the cluster. There you go. So it's up and running. The install is still continuing, and literally just in a few seconds. So probably different than what you're used to with live migrations. And I want to show you here a quick recording of a similar 3-node cluster. And what happens here is I pull the power on the 3rd node in the cluster. So you're going to see that gray out and some alerts pop up in the UI. But most importantly, in just a few seconds, you will see the applications that were running on node 3 report now as running on node 2. So even in catastrophic failure, the system is able to keep the applications up and running. And so this is actually demonstrates 2 things at once. It's a combination of the way that HCI storage stack works, where even though I've lost multiple drives simultaneously in my environment, I had another active copy of every block of data that was on node 3 existed somewhere else. And so I can keep that application up and running. And second, is that AIOps engine. So we detect things are happening. In some cases, like it didn't know I was going to pull the power, but it might, proactively live migrate workloads in order to keep them running, shut nodes down, restart services, all of those sorts of things in the name of keeping your applications up and running. So that's your local high availability that's built in. Second, I want to talk about disaster recovery. So I mentioned that was built in as well. So here again is that virtual machine that we just created and still installing. And if I click a button here, you'll see it says set up replication. When I click that button, it's going to give me a drop-down box of any other cluster which I've given this cluster access to. So I'm going to pick this one called Maverick, hit replicate, and literally that is all it takes to set up disaster recovery. So what's going to happen here, the system is going to take a snapshot of that running virtual machine and its underlying storage. It can take thousands of snapshots without a performance hit. And it's going to then replicate on whatever schedule I select. I went with the default, which is every 15 minutes, but you can do it however you like and set your retention schedule however you like. But the point is, in 2 clicks, I have now created disaster recovery. If this site fails and all 3 nodes were to go offline, I could simply point my DNS over to the Maverick cluster and have that application up and running. And in fact, if I jump over to the Maverick cluster here, we should be able to find, there it is. So it's not replicated yet. As you can imagine, it's got to send some data over the WAN, but the snapshot, it's coming in and it'll complete. And as soon as it's done replicating, we'll get a timestamp here of that. And again, you'll get a copy of all the snapshots, if you want all of them, of course, but you get a copy of all the snapshots that exist locally at that DR site. So again, that's completely built in. The other thing I want to show you is some of the zero-touch deployment capabilities that come with Fleet Manager. So if I come over to my Fleet Manager instance again, in this cluster view, you'll see there's a button that says Add Cluster. So when I click that, I can give and say, okay, I'm going to deploy, give it a name, give it its basic IP information. And you see this button says Add Node. When I click Add Node, what I'm actually looking at here is a list of all of the assets I have purchased from Scale Computing. So we're talking about software licenses and so forth. So I can say, oh, even if I haven't deployed or if I bought an appliance that hasn't even shipped yet, I can pick and say, oh, I want to add, this node over here and this node here, for example. And they'll pop up in the environment for me to use. And I'll give, basic IP address information to those nodes. So you can see, here's the node there and its serial number and so forth that are going to go. What will then happen is when that node comes to life somewhere in the world and connects into Fleet Manager, it's going to get its information. I can tie this into an Ansible playbook to download my applications and so forth, and completely autonomously set up the system. So in fact, I will show you just a quick recording of my nephew, who is 8 years old, who agreed to stand up a cluster for me in his bedroom. So again, this was pre-configured in Fleet Manager with all the information. So he's kind of mimicking, it might be your store manager at a remote site. Rather than send an IT team out with a truck to configure everything, literally all we have to do is plug in network and power and turn this thing on. Once it comes online, as I mentioned, it's going to reach out to Fleet Manager, download its configuration, download the applications that it needs, configure those applications, and you wait for the light to turn green. So we got a thumbs up from John that our node is up and running. Now, likewise, I recruited John's younger sister, Elizabeth, to show us what happens in a break fix scenario. So in this case, we had a 3-node cluster, similar to what you saw there, and one of our nodes has failed. Maybe the power supply died or what have you. So you can see one of those nodes is offline. What we've done is we've shipped a device to Elizabeth. And what she's going to do, again, with that zero-touch configuration, all she has to do is plug it in. It knows it's supposed to join the cluster. It joins the cluster, and then it will pop up in Fleet Manager now as having that new node online, config itself, download its applications again, join the cluster, etc. So your initial deployment is trivially easy. Your break fix is very easy. And from there, you are good to go. So let me wrap up by showing you, oops, here we go. Talking very briefly about about migration. So within the product itself, you can directly do things like import VMDK files, import QCOW2 files, and literally just drag and drop your applications into HyperCore and be up and running. That might require some downtime. You got to do the export and the import. You can also use tools. There's a free tool from Acronis, for example, allows you to set up scale effectively as a replication target for your existing environment, whatever it may be. So maybe it's VMware or something else. You're going to replicate from there to scale. And once it's up, you just fail over and never fail back. So that becomes a zero downtime kind of migration. Very, very easy to do. You can actually use both. You can make us a DR target for a different platform or vice versa using that tool, or you can do the direct import as I talked about. So thanks so much for joining me today. Again, my name is Jeff Reedy. My email address is jeff@scaleComputing.com. I would love to hear from you. I'd love to answer any questions you may have or help you out on it next deployment. Thanks so much.